All right, so this next part is asking determine whether the table or rule represents a linear or exponential function. Okay, two options for every answer. You got to either identify it as linear or exponential. So for these next four questions, you either see an equation or you see a table for all four examples. And you got to say if it's this, this, or neither. So if we look at example A, let's look at the table. So we notice, and if you guys remember way back to like chapter like 4 or so, or chapter like the one section we did, chapter 3, what we got to do here is we got to figure out, okay, what is the rate at which this thing is going up by? So if we look just at the x column, to go from 1 to 2, we ask ourselves, okay, what do we got to go up by? We have to go up by +1. To go for 2 to 3, it's another +1, and then 3 to 4, it's another +1. Okay, so for the x column, we're going up by the same thing every single time. And if this thing is linear, the y column is going to do the exact same thing. It's going to go up by the exact same every single time. So to go from -1 to 1, what do we have to do? We have to add 2. To go from 1 to 3, what do we have to do? We have to add 2 again. To go from 3 to 5, what do we have to do? We have to add 2 again. So because both the x and the y column are going up by the same rate every single time, we know that is a linear function. Okay, linear is the answer here. For example B, it's giving you an equation. Y is equal to 3 times 6 raised to the x power. Okay, so to determine if this is linear or exponential, we check first, is it linear? Does it follow the format y equals mx plus b? No, this does not look like that at all, so we know it's not linear. But does it look like the exponential function equation? Does it follow the format y is equal to a times b raised to the x power? So it does look pretty similar, a and a, b and b, and then variable for the exponent. Then we just got to make sure, does it follow those properties? Okay, remember, does a cannot equal 0. Okay, a is 3 in this case, it does not equal 0. And then b has to be positive and it can't equal 1. Okay, 6 meets both those requirements, so yes, this is an exponential function. This is exponential. Okay, for letter C, this looks pretty similar to that format y is equal to a times b raised to the x power, but we do have to remember one of those rules. Remember, whatever letter, or whatever number rather, is attached to the exponent has to be bigger than 0. B must be bigger than 0. Okay, but in this case, it's not. It's a negative number. So because b in this case, the number that's attached, the base is not positive, this is not exponential. It's not exponential, it's not linear, so it's, we'll call it neither. Okay, and then for letter D, we have another chart. So the first thing we always do is check, is it linear? Are you going up by the same thing every single time? So in the x column, it looks like every single time we're going up by 10. Okay, so that's a pretty good start for linear. But we notice in the y column, to go from 10 to 25, we got to go plus 15, and then from 25 to 62.5, it's not plus 15. So it can't be linear, but here's how you check if something is exponential. Okay, for linear, you have to add the same thing every single time, but for exponential, you have to multiply by the same thing every single time. So we ask ourselves, okay, to go from 10 to 25, what do we have to do? What do we have to multiply 10 by to get 25? Okay, so you could guess and check through a calculator, or you could do this little division. To go from 10 to 25, you have to multiply by 2.5. Okay, but if you go up by the same multiplication rate every single time, it's an exponential function. Okay, so you ask yourself, okay, to go from 25 to 62.5, what do we have to do? And you'll realize, once again, you have to multiply 25 by 2.5 to get to 62.5, and it works again. And then check the last one, 62.5 times 2.5, once again, gets you to that final number of 156.25. Because you multiply by the same thing every single time to get from one number to the next, this is called an exponential function.